We're looking at solutions to systems of equations, and you might ask the question, can I decide just from looking at equations whether or not there is a solution, and if there is a solution, how many? So that's the question we'll look at here. How to determine the number of solutions to a system, and in particular we're going to compare the slope and the y-intercept. So there are three ways this can work out. We might have exactly one solution. That's when we have different slopes, the lines cross, and we call that a consistent system. It might be that there's no solution. If the equations have the same slopes and different y-intercepts, they're running parallel to each other. And remember, a solution to a system is the point where they cross. Well, if lines run parallel, they're not going to cross. And finally, we may have infinitely many solutions. That's going to happen when we really have the same equation. So we're going to have the same slopes and the same y-intercepts. We call this a dependent situation. And the no solution was inconsistent. Let's look at some examples. We're going to use equations that are in the form y equals mx plus b, the slope-intercept form. And we'll just compare slopes and y-intercepts and see what we've got. In the first set, we have y equals 2x plus 6 and y equals negative 2x plus 6. The important place to start is the slope. Here we have a 2 and a negative 2. Since the slopes are different, we don't need to look any further. These lines have to cross somewhere. This is a consistent system, and it has exactly one solution, one ordered pair, one point where those two lines will cross. Let's consider one that looks almost the same. All of these look pretty close to each other. What about negative 2x plus 6 and negative 2x plus 6? Well, they have the same slope, and they have the same y-intercept. So if we were to graph these two lines, we'd end up with two lines right on top of each other. This is a dependent system, and there are infinitely many solutions. The whole line is the solution. Finally, let's look at y equals negative 2x minus 6 and y equals negative 2x plus 6. Again, they have the same slope, so we need to move on and check out the y-intercept. One of them has a y-intercept of negative 6. The other line has a y-intercept of positive 6. If we were to graph these, they would more or less have this shape, or this appearance, the picture. Those are two parallel lines that will never cross. So this is an inconsistent system, and there are no solutions. Now, I chose these examples where the numbers all look so much alike because it's easy to get in a hurry and miss the little differences. So no matter what numbers are on the paper in front of you or on an exam, you need to take the time systematically to compare the slope. Are they the same or different? And then the y-intercept, are they the same or different? And mind your signs. And that concludes this example.